sure all the letters are what the students should have been taught according to the guide. The right notation has been used, because if your teacher tells you pi is 180 degree and suddenly somebody is bringing rho as 180 degree, but students are not used to this notation, people check for that. Maybe the same set of people or maybe another set of people will check for ambiguity. If this paper is given on that table, is that question likely to be interpreted more than one, way? And if that is not the intention of the exam body, that ambiguity must be removed. So that when we create a mark scheme, we're not going to say mark scheme for Jensen, mark scheme for Rita, mark scheme for you, mark scheme for you, mark scheme for you. We're not going to say that. There's only one mark scheme. So that means the question must be free of ambiguity. It must be free from the idea that it is open to more than one interpretation. It must be only one interpretation. I'll give you an example. Two boys are 5 meters apart, or maybe, okay, two boys stand and sight a flagpole. We have not told you whether the flagpole is in the middle of the two boys, or maybe the two boys are on the same side of the flagpole. That's an ambiguity. Unless there are additional information that can justify that they are on the same side or opposite side, whatever solution you have provided in that problem of angle of elevation and depression, you are right. But it shouldn't be like that. So they will have to remove that ambiguity. Ambiguity means it is open to more than one interpretation. That is why we call this ambiguous case of the Sine Rule. And it's in your textbook as well. It means Sine Rule problems that are open to more than one interpretation, as long as the two interpretations are valid. Because there are instances where they are not valid. And I will show you one by playing one example. Now, we got 56, which is this one. So the question now is, how do you get this one? I want to show you something. Bring out your calculator. Sine theta, sine 180 minus theta. Pick any theta of your choice. I need you to pick an angle less than 90 and do 180 minus that same sine. Then I need you to pick an angle more than 90 in the second quadrant. Okay, that's from 90 to 180, and do the same thing for this. I need you to pick an angle that is between 180 and 270 and do the same for this. Then I need you to pick an angle between 270 and 360 and do the same for this as well. Am I making sense? Yes. So for example, sine 30, sine 180 minus 30. Sine 150, sine 180 minus 150. Maybe sine 220, sine 180 minus 220. Maybe sine 310, sine 180 minus 310. Something like that. Tell me what you notice in each of these cases. Please don't talk unless you figure something out. Don't tell me you know what I'm talking about. Please let people investigate with their calculator. Quickly, are you done? Rita, what do you notice?
Sine theta is equal to sine 180 minus theta.
Ryan, did you do it? So sine theta is sine 180 minus theta. We will go into maybe equation. I will go deep into understanding trig later. Then we will talk about it. But we need the idea now. And that is what you will do next. Because this is arc sine. What this means is that I'm trying to find an angle whose sine is 5/6. Does that make sense? If I'm trying to find an angle, now you have done sine 30, you got 0.5. and you must have done sine 150. Similarly, you get 0.5, right? So if someone says that sine of an angle alpha is 0.5, it is open to two different interpretations. So when you say alpha is arc sine of 0.5, your calculator will only give you 30 degrees. But because you should know this identity, you will have to say, or alpha is also 180 minus that same 30 degree. Because they are supplementary angles. So alpha is 150, and that is how you get the two values. And that is what you will do here. Or z is equal to 180 minus that answer. And z is equal to what? 123 points. And that should be something that you have gotten for the second diagram, or close. Yes? So these are the two interpretations. However, you have to be careful here. However, we must check each time if both are indeed valid answers. The first one definitely wouldn't have a problem. Even though the sine rule ambiguous case can give you the second solution, you must check if it is valid. How do you check? Add this to 30 degrees, you get 150 something. Right? So we are talking about this. This is the one we are talking about, 123.6. If you add it to 30, you're going to get 150 something. So which means this angle is still greater than 0. Are you with me? But if, for some reason, after we calculate, we get, say, 160, you don't stop there. Even though this 160 might be a valid answer for this equation, that 160 is not valid here. Can somebody tell me why? It's already bigger than 180. So such a triangle does not exist. In that case, you ignore that solution. But of course, you have to show us why you are ignoring the solution. So in that case, I would say, oh, but 30 degrees angle x plus angle z is 30 plus 160, which is 190, which is already greater than 180 degrees. Therefore, this solution is invalid. Therefore, z is equal to 56.4 is the only solution. Does this make sense? Let me play you one example. Oh, really? Okay, I'll pay. Wait for me! Wait for me! I think they finished the exam. Okay, so let's see this. So this is the investigation you have just done. I need can you move that, Mr. Jensen, to the board? Oh, wait. Yes, sir. Please pay attention.
In this question, we are given some information about triangle ABC. We sketch the triangle showing the information provided. We are given some information about triangle ABC.
Joey?
We sketch the triangle showing the information provided. We are asked to find the angle at C, which is opposite a known side length. We already know another angle and its opposite side length, so this tells us to use the sine rule. Now, in the previous example, we used the sine rule to find an unknown side length. When we do this, there will always only be one solution. If we use the sine rule to find an unknown angle, we must be aware that there might be two possible solutions. We call this the ambiguous case. We substitute the side length opposite C, the angle at B, and the opposite side length, and then isolate sine C. Since C is an angle of a triangle, it must measure between 0 and 180 degrees. But we know that for an angle with a positive sign, there will be two angles between 0 and 180 degrees. One of the possible measures for the angle will be the inverse sine of the given expression,
Can you see
and the
those
other
arrow
will be
points?
the supplement of this angle, which means 180 degrees minus the angle. We use our calculator to evaluate the inverse sine, so we have two possible values for C. One is acute and the other is obtuse. The other known angle of the triangle is 25 degrees. We know that the angle sum of the triangle must be 180 degrees, so either value for the angle C is possible without exceeding this total. We therefore conclude that both angles are possible. There are two possible triangles which satisfy the given information.
Does this make sense? So those are the two possible triangles. But if you are not asked to draw, please do not draw the two possible triangles. Find the result, stop there. Okay? Of course, if it is a word problem, you are welcome to sketch. It's okay. You are welcome to do that. But not completing this and then going about and drawing the two shapes is not necessary. So now, let's see the case where one of them is not valid. Come on. Okay.
This example
Oh.
is one, but there isn't. This example is very similar to the previous one, but there is an important difference in its ending. We will again start by using the sine rule to determine an unknown angle in a triangle, and we'll have to again consider the possible solutions carefully. We start by drawing a triangle using the information provided. We are asked to find the angle at L, which is opposite a known side length. We already know another angle and its opposite side length, so this tells us to use the sine rule. We substitute the side length opposite L, the angle at K and the opposite side length, and then isolate sine L. One of the possible measures for the angle will be the inverse sine of the given expression, and the other will be the supplement of this angle, which
Listen
means
carefully to the
180
concluding part of this
degrees
one. Very
minus the
important.
angle. We use our calculator to evaluate the inverse sine. So we have two possible values for L. One is acute and the other is obtuse. However, one of these values is not possible. Can you see which one and why?
Can you see which one?
In this case, the other known angle of the triangle is 56 degrees. If we add that to 138.2 degrees, we exceed 180 degrees. This is impossible for a triangle, so we have to reject 138.2 degrees as a possible solution. The unique solution for the angle L is about 41.8 degrees. There is only one triangle which satisfies the conditions in this problem.
Does that make sense? So after you check for the ambiguous case, you solve the two, whatever, you must check this and reject which one is not valid. And you must show how you have rejected it. And you conclude that, oh, there's only one unique solution here. Otherwise, you show us the two solutions. Okay? But to check the second one, you may not bother to show us that. But I would suggest you do. That, oh, maybe since 30-something plus 150, 120-something is still less than 180, then the two are valid. Maybe we should stick to that. Understand? So you have your worksheet. Thank you very much. Please do something before you go.